In this presentation, we are going to present our project on smoke and poison gas detection system. So this project was complete as our assignment task, and our group member is Lim Bing Sheng, Ngoi Yuk Loong, Nicolas Sii Tiing Kie, and Yeap Zhuang. So our lecturer is IRTS Dr. Anwar bin Jafar. So we will take you go through all aspects of our system. So next is content. We will go through all of this section and will give you a comprehensive understanding of our project. Next slide is about the project. So the smoke and poison gas detection system is designed to enhance safety by providing early warnings of hazardous gas concentration and smoke in the environment. The core of our system is a Raspberry Pi 3, which serves as the central controller. It integrates an MQ2 gas sensor, a buzzer, and a LED. The MQ2 sensor is capable of detecting various types of gases, including smoke, methane, butane, and LPG. When the sensor detects dangerous levels of gas or smoke, it triggers the buzzer and light up the LED to alert the individual of danger. So this system is particularly valuable in enhancing safety across residential, industrial, and commercial environments. One of the key advantages of our design is cost effectiveness. We have used affordable components, making the system accessible and scalable. So this means additional sensors and features can be easily integrated as needed. Our project not only aims to provide a reliable safety solution, but also to demonstrate that such systems can be developed economically, making them viable for widespread adoption. So next slide is objective, and our project has three primary objectives. So for the first objective is to enhance safety by providing early detection and alert for smoke and toxic gases in the environment, ensuring timely evacuation and response. For second one is to create a cost-effective and efficient gas detection system suitable for various applications. So and the third one is to increase awareness and preparedness in residential, industrial, and commercial setting by integrating visual and audio alert mechanism for immediate hazard notifications. So these three objectives guide our project development and implementation, ensuring that it meets the needs of various environments while prioritizing safety and cost effectiveness.
So we continue with the system overview and broad diagram. So there are four components that we use in our project, which is MQ2, Raspberry Pi 3, and LED with buzzer. So for the MQ2 sensor is widely used for gas leakage detection in homes and industries. It is capable of detecting various gases, including methane, butane, liquefied petroleum gas, and smoke. And I will give some primary function features of MQ2 sensor, which is gas detection. The MQ2 sensor is primarily used to detect combustible gases such as methane, butane, and propane, as well as other harmful gases like carbon monoxide and smoke. After that, MQ2 sensor is also high in sensitivity. It is a high sensitivity to a wide range of gases, making it suitable for various applications where gas leakage detection is critical. Followed by MQ2 sensor also provide both analog and digital outputs. The analog outputs provides a voltage that is proportional to the concentration of the detected gas, while the digital output can be used for triggering alarms or other devices when the gas concentration exceeds a certain threshold. So for the Raspberry Pi 3, it is used to code the program and to control the output of the LED and buzzer. Well, for the flowchart, First, the project will start with detecting the gases with MQ2 sensor. If the MQ2 sensor is equal, input is equal to 0, the red LED will turn on, and the buzzer will turn on, which will later print on the monitor there is no poison gas, and will end the process. But if the MQ2 sensor is not equal to 0, the red LED will be 0, and green LED will be 1. It will be triggered, and also bring no poison gas. Then it will feedback to the start again and loop it. Well, for the schematic, this is the schematic diagram of our circuit, which the GPIO13 will be connected to green LED, and GPIO11 will also connected to red LED, while the GPIO7 will connected to the output of gas sensor MQ2. Well, GPIO15 in the Raspberry Pi pin will connected to the buzzer. That's all for this part. Thank you.
For the coding, first step is to import rpi.gpio as GPIO. rpi.gpio is a library to control the GPIO pins on a Raspberry Pi. Second is import time. It is used for adding delays in the script. And set the pin numbering mode to the physical pin number, and then disable the channel already in use warning. Then defining for the pin numbers. For gas sensor input is 7, red LED is 11, green LED is 13, buzzer is 15. And then set the input and output of those pins. In the while loop, if the gas sensor detects 1, which represents no poison gas, the green LED will be lighted up, and red LED and buzzer is off, and print the no poison gas. If the input detects 0, the red LED and buzzer will be on, and the green LED will be off, and then time sweep for 1 second before returning to the loop. Lastly, GPIO.cleanup is to reset the GPIO pin while exit. Let's run the program. We can see there is no poison gas, and the green LED is lighting. Here we can see the GPIO by typing GPIO read all. We can see here the physical pin 7 is GPIO7 and it is in input mode. The pin 11, 13 and 15 is equivalent to GPIO 0, 2 and 3, and they are output mode. The voltage of pin 7 is 1. This represents there is no poison gas. And the output is the pin 11 is 0, and pin 13 is 1, and pin 15 is 0. Now let's put this alcohol to the sensor to trigger it. Now the red LED is on and the green LED is off. And the buzzer is producing sound. Here shows there is poison gas. Type the GPIO read all and see again how is the GPIO pin. So now the GPIO 7, which is pin 7, is now 0, and pin 11 is 1, pin 13 is 0, and pin 15 is 1. Here is the comparison of that two states. For modification, let's change this pin 7 to pin 19 and then run. Here is pin 19 is 0, so the buzzer is on. Here also change the pin 7 to pin 19 for the input pin of the sensor. And then run the GPIO read all. We can see the pin 7 back to the default, and then the pin 19 is 1 for now, and the output for 1 is 0, 1, 0. Let's trigger the sensor. Now the input changed to 0 and the output is 101. It shows that this modification is successful. For the FQA, first question, what is the purpose of the GPU during the Raspberry Pi boot process? The GPU executes the first stage bootloader from ROM, loads subsequent boot files, and initializes the system's SDRAM before handing control over to the ARM CPU cores to start the operating system. Second question, how can we monitor virtual memory usage on the Raspberry Pi? Use the vmstart command in the terminal to summarize the current state of the virtual memory system. For example, vmstart interval count displays updates at specified intervals and counts. For question 3, what is the key differences between GPIO input and output modes? Output mode configures a GPIO pin to send signals, for example, to light an LED. Input mode configures a GPIO pin to receive signals, for example, from a button. It often requires pull up or pull down resistor to avoid floating states. Question 4. How can we ensure reliable input detection on GPIO pins? Use internal pull up or pull down resistors in the GPIO setup to ensure the pin reads a definite high 3.3 watt or low 0 watt state, avoiding ambiguous floating states. For example, GPIO setup pin GPIO in pull up down equals GPIO.BOARD up. For question 5, what are the steps to configure Wi-Fi on the Raspberry Pi? Open the Wi-Fi configuration GUI, WPA GUI, scan for available networks, select your network and enter the PSK, which is password, and connect. Alternatively, use ifconfig and iwconfig commands to manage network interfaces via the terminal.
Hi, my name is Nicolas. Today I will present the discussion and conclusion part for our smoke and poison gas detection system. So the most smoke and poison gas detection system built with a Raspberry Pi 3, MQ2 gas sensor, buzzer and LEDs offers an effective solution for real-time monitoring of hazardous gases. The system continuously checks gas levels and triggers visual, which is LED, and audio, which is buzzer alerts, when hazardous concentrations are detected, ensuring immediate awareness and response. The Raspberry Pi 3 processes sensor data and manage the alert mechanisms. Green and red LEDs indicate normal and high gas concentrations, respectively, allowing for quick visual assessment. The buzzer ensures immediate auditory warning, crucial for timely response. So the conclusion is this project demonstrates the practical application of accessible and affordable technology for enhancing safety in various environments. The integration of simple hardware and straightforward software logic ensures reliability and efficiency. Overall, this system provides a robust and scalable approach to safeguarding lives and property by enabling early detection and timely alerts for smoke and toxic gases. Thank you.